In this video, we'll be looking at the equation of a straight line, or the straight line equation, which is in white and is y equals mx plus c. And this is the most common form of the straight line equation that you will see at GCSE maths. So if you've watched my gradient video, you'll know that m is the letter most commonly used to denote gradient, and we'll also explain that plus c is the y-intercept during this video. So we have here a straight line on a set of axes, and the equation of this straight line is y equals 2x plus 1. We can check that the gradient is 2. For every 1 we go across, we go up by 2. For every 1 we go across, we go up by 2. So let's turn our attention to the plus 1. We can see that the yellow line crosses the y-axis at the coordinate 0, 1. So that means that the y-coordinate of that intersection point is 1. So we know that the straight line equation from before is y equals mx plus c. So we know from before that our m is the gradient. And now we can see that our plus c corresponds to the y-intercept. There's a few ways of checking that the plus c is in fact the y-intercept. The first method that I will show you is where we set our equation to cross the y-axis. Now, every single point on the y-axis has an x-coordinate of 0. Doesn't matter which point you pick, its x-coordinate will always be 0. So we can set x to be equal to 0, substitute that in to the straight line equation without plus c. So what I mean by that is y equals 2x plus c. We know that the gradient is 2. We substitute 0 for x in there. We get y equals 2 times 0 plus c. And we can see now that y just equals the value of c. So when x is 0, or we're on the y-axis, the y value of that point is just going to be plus c in the equation. We can see that the c is in fact where our graph crosses the y-axis. Whatever the y value is at the y-axis, that is what plus c is equal to. Another method of finding what plus c is, without even looking at the axes, we can pick a point that is not on the axis. So let's say this one here, that point is 1, 3. This is a set of x and y coordinates, right? So we can plug those into our equation. An equation in maths is just a mathematical expression that satisfies that the left-hand side is in fact equal to the right-hand side. Now, any point on our straight line, our yellow line drawn here, will satisfy that equation y equals 2x plus 1. So we can show that by first figuring out the gradient, and now taking this point and inserting it into our equation. That makes it 3 equals 2 times 1 plus c. If we rearrange this, we find that c equals 1. Okay, and that is our y-intercept for this straight line. Let's take a look at this example together. So we're going to try and find the equation of this straight line on my set of axes. First thing that I'm going to do is find the gradient. What I'm going to do is I'm going to pick 2 points on the graph. This one here, 0, 1, and this point down here, 1, minus 2. I'm going to do the change in the y direction, so minus 2 minus 1 divided by the change in the x direction, which is 1 minus 0. So that works out to be minus 3. So the next step that we'll do is we'll take our straight line equation and plug in some known values. So what does this look like? Well, we take y equals mx plus c. I'm just going to write it out in full first. Now we can replace m, which is the gradient, with minus 3. And to work out what plus c would be for this particular line, I can now plug in a coordinate that I know lies on it. So I'm going to pick 1 minus 2, or I could pick 0, 1. In fact, that would be easier here. So y value is 1, that equals minus 3 times 0 plus c. So c for this line equals 1. Now I can go to my final step, which is simply to write the full equation. Okay, so our final answer is just going to be y equals minus 3x, gradient being minus 3, and the final y-intercept being plus 1. So a lot of people are confused about this second step where I'm talking about plugging in values into the straight line equation. We have to understand that any point that lies on our straight line is able to satisfy that particular equation. So placing any pair of x and y coordinates into my straight line equation at that stage will get the same value of plus c, hopefully, if we do all of our calculations correct. Now we can also check our final answer to the graph. We can see that the graph clearly crosses the y-axis at plus 1, and yeah, my plus c there is in fact plus 1. Let's have a look at one last example together. I've got my yellow straight line here on my coordinate grid. Now, following the steps from last question, the first thing that I'll be doing is working out the gradient. I'm going to pick this point here, which has coordinates 0, minus 2. I'm going to be picking this point here, which has coordinates 3, 0. Using my equation for the gradient, I'm going to do 0 minus 2 divided by 3 minus 0. So that works out to be 2 over 3. That's my gradient for this yellow line. And one thing that I like to show students at this stage is if we just add in a second line with the exact same gradient, okay, you can see that it doesn't matter where I move this line on the axes, it's going to have the exact same gradient. The thing that is changing, if we turn our attention to the y-axis, is where the line crosses it. Okay, and that's why it's so important to use a point that lies on this straight line to do the final calculation, that second step, that substitution step. So let's do just that. I'm going to pick a third, doesn't matter, random point on the line. So this point here is 6, 2. So that's the x and the y value that I'm going to substitute. So as before, I'm going to work through substituting one thing at a time. So placing in the gradient first, 2 over 3. Now placing in that coordinate. Okay, and now let's just solve this. And we find that c is minus 2. If we turn our attention to the graph, we see that on the y-axis, the yellow line does in fact intersect with that there at minus 2. So the y-intercept is indeed minus 2. We've calculated it, and we've seen it on the graph as well. And that is how to find the equation of a straight line on a set of axes.